This video introduces a visual analytics system, NFTracer, designed to trace the impact dynamics of NFT projects in their substitutive systems. First, what's an NFT? NFT stands for non-fungible token. Unlike fungible items can be replaced by another identical one, an NFT is a unique and immutable digital certificate stored on a blockchain, which ensure the ownership of digital assets. NFTs can be associated with anything unique. People use smart contracts to record metadata during transactions to realize the function of NFT as digital certificate. However, the lack of assessment metrics for NFTs has long been a pain point that jeopardizes the development of NFT marketplaces, which motivate us to create NFTracer for stakeholders' benefit. This is the interface of NFTracer. Propensity Analysis View provides a control panel for time slicing and attribute selection to cluster NFT projects. Mechanism Analysis View displays distributions of mechanisms and impact dynamics for intergroup comparison. Substitution View illustrates the migrated stakeholders among NFT projects through a node-link graph. An Impact Dynamic View contains a preferential attachment view to compare co-occurring stakeholders and an individual evolution view for inspecting and comparing growth pattern of individual NFT projects. Let's illustrate this with an example workflow. Users can start by selecting time windows and impact attributes in Propensity Analysis View. Besides, users can adjust the cluster method and group numbers until satisfactory results are yielded. NFTracer would automatically identify and cluster NFT projects existing within the duration accordingly. Simultaneously, the Substitution View will display the overview of NFT projects allocation within the Substitution Wheel, with the Mechanism Analysis View exhibiting the intergroup distribution of mechanism values and impact dynamics. The glyph design of individual NFT projects is three-layered. The top layer shows NFT project logos. The middle layer displays a pie chart of current buyers, sellers, and holders. The bottom layer uses a donut chart to represent the relative values of three mechanisms and the impact dynamics of NFT projects. Now let's get back to the workflow. At this step, users can highlight a project in Substitution View to investigate the substitutive network centering on the specific NFT project. We offer two sparse configurations for inspecting substitution flows, the fisheye view and the square view. Both preserve the relative positions of the nodes denoting projects. User can also filter a group to identify the mutual substitution flows of NFT projects within the group and how different mechanisms affect. The Impact Dynamic View provides a two-dimensional comparison, co-occurring stakeholders and the temporal progression of stakeholders' transaction behaviors within the selected group. The legend in the upper left corner represents the co-occurring buyers, sellers, and holders between paired projects. By clicking glyphs in the set matrix, show short vertical lines in the right histograms, indicating stakeholder co-occurrence in each category. Furthermore, users can explore and compare growth patterns of paired NFT projects by observing the evolution of the number of stakeholders, mechanisms, and impact dynamics. Finally, users can select individual NFT projects by names in the Mechanism Analysis View to explore the specific mechanism values. In Case Study 1, the domain expert characterized the growth patterns of healthy NFT projects by sequentially utilizing Propensity Analysis View, Substitution View, Mechanism Analysis View and Impact Dynamic View to derive features of healthy projects. He found that groups of healthy NFT projects tended to obtain lower similarity values, indicating unique growth patterns with a higher possibility of survival. Also, values of preferential attachment mechanism decreased evenly in well-performing project. Hence, he summarized that stable and gradual change in mechanism is the key to maintaining a healthy trend for NFT projects. Then he utilized Substitution View and Impact Dynamic View to characterize the developing trend of unhealthy projects. He observed the substitution flows in the Substitution View and noted an escaping trend of stakeholders owning aforesaid project, presenting a failure in maintaining attractiveness to stakeholders. Furthermore, their recency mechanism values tend to be relatively low, indicating a deficiency in communication between the project launcher and stakeholders. Therefore, he came to the insight that dropping stakeholders' attention and interest can lead to unhealthy churns. In Case Study 2, the domain expert sequentially explored Substitution View and Mechanism Analysis View. As a result, he finds that NFT projects featuring a higher degree of similarity are more likely to substitute for each other. Next, he investigated the set matrix and the temporal impact dynamics evolution in the Impact Dynamic View to compare two similar NFT projects. He summarized that competitive NFT projects akin to mechanism distributions are negatively correlated in impact dynamics values.